Hello student, myself Sanjay Sharma. I am a physics teacher from Rishiguru Vidyapit Sonipat, and again here with my third module of class 12 electrostatic unit. And the topic is electric field. Basically before electric field one more topic was there, that is the superposition of charges, but that is the numerical part, so I will make a different module for the numerical part. Okay, so that's why I am starting here electric field. The question arises, what is the meaning of electric field? You all have studied in your 11th class gravitational field. What was that? Just remember it and try to listen what I am saying. If we are having a test source charge plus q, then the free space around this point charge in which any other test charge experience the force of interaction exerted by the source charge, that free space is called as electric field. Here this is positive q charge and this is positive q naught charge. So here this positive q charge is repelling, is applying force of repulsion on this test charge. So here at point P, let's say that positive test charge is present, it experiencing the force of repulsion. But if the test charge is present here and test charge is not experiencing any force exerted by the point charge, then we can say that in this condition this test charge is out of the electric field of the source charge. But in this case here at point P, the test charge is present and this complete boundary surrounded portion of the source charge in which the test charge is experiencing the force of interaction exerted by the source charge is called as electric field. Now the term comes, that is electric field intensity. Electric field intensity. Electric field intensity formula I am telling you, that is equals to force acting on per unit test charge. This is a vector quantity data, so we can write in vector just like this. Here the unit of electric field intensity is Newton per Coulomb. The electric field intensity unit is Newton per Coulomb. One theoretical aspects is here. According to theory, electric field extended up to infinitum, but practically it have a limited portion. So this is the thing which you have to remember in your mind. Next, electric field intensity, I told you already. What is the physical significance of electric field? So that I am telling you, the physical significance of electric field, from this formula you can write in magnitude. In magnitude, you can write F equals to test charge multiplied with the electric field. So the physical significance of electric field is, it tells us about the force acting on the test charge and the direction of force acting, you can say experienced by the test charge. And whatever the electric field is here, that is independent of the presence of test charge. There will be no change in the electric field value due to the presence of the test charge, because it is very small in amount. That's why here electric field value will not change due to the presence of test charge. Now, if we want to find out electric field intensity due to a point charge at any point, electric field, field intensity due to a point charge at any point, electric field intensity due to a point charge at any point, electric field intensity due to a point charge at any point, electric field intensity due to a point charge at any point, electric field intensity due to a point charge at any point, electric field intensity due to a point charge at any point, electric field intensity due to a point charge at any point, electric field intensity due to a point charge at any point, electric field intensity due to a point charge at any point, electric field intensity due to a point charge at any point, electric field intensity due to a point charge at any point, electric field intensity due to a point charge at any point, electric field intensity due to a point charge at any point, electric field intensity due to a point charge at any point, electric field intensity due to a point charge at any point, electric field intensity due to a point charge at any point, electric field intensity due to a point charge at any point, electric field intensity due to a point charge at any point, electric field intensity due to a point charge at any point, e intensity at any point due to a point charge. So that we can find just like this. See beta, here if we have a source charge Q, you can say positive Q, which is present at point A, and a test charge is at point B, which we have considered like Q naught. So you all understand both are positive, so the test charge will experience repulsive force exerted by the source charge. So what is the value of Coulomb force now? According to the expression of the Coulomb force, we can write 1 upon 4 pi epsilon naught Q naught upon the distance between AP, let's say R. So it is R square. Now, the electric field intensity equals to force upon test charge. So now it becomes, what is that? 1 upon 4 pi epsilon naught Q naught upon R square into Q naught. Q naught is cancelled out with this Q naught. So finally, electric field becomes 1 upon 4 pi epsilon naught Q upon R square. This is the expression for electric field intensity at any point P. Here, from this expression, we understand that E is inversely proportional to R square. It means if we increase the distance R, then electric field will decrease because it is inversely proportional. So if we want to make a graph, or you can say relation, graphical representation between E and R square, then what will happen? If we are taking R square here and electric field here, then you can see R square and E both are inversely to each other. So when we increase R square, then electric field start to decrease. But if we will make a graphical representation between 1 upon R square and electric field, then what will happen? In this case, I am not saying R square will increase. I am saying 1 upon R square will increase. Just think on in your mind. 1 upon R square will increase when R will decrease. So, when 1 upon R square will increase, then the graph comes just like this straight line. This is the graphical relation between electric field R squared, electric field 1 upon R square beta. Now, we have to come on electric field line of forces. So, for that, I will write here, see, electric field line of forces. So how can we explain what is electric field line of forces? Before to explain the definition of electric field line of forces, I am just telling you with the help of small activity. If I am having a positive charge here, and just consider in your mind, as we have placed, let's say, just assume it, you can say, unit positive charge at some distance, then what will happen? Due to the positive charge, this positive charge will move away, mean it will experience repulsive force. It will reach here, then again what will happen? Again it will experience repulsive force, it will reach here. Again what will happen? It will reach here. Again what will happen? It will reach here. So, if we unit positive charge will place here, then what will happen again? See, it will repel. Again, it will repel. Again, it will repel. So if I will show with the help of an arrow the exact path of the movement of the test charge, with the help of this arrow, if I am showing it, then this arrow line shows the electric line of force due to the point charge. So what you understand about it? Electric line of force is the imaginary line of force which is actually the path traveled by the unit positive test charge under the influence of source charge. If the test charge is present here, then the line of force may be this. If the test charge is here, then the line of force may be this. If the test charge is here, then the line of force may be this. If the test charge is here, then the line of force may be this. So electric line of force may be straight or it may be curve also, beta. So in case of curved line, that's when they think about that how the electric line of force may be curved. That I am telling you. See again. How the electric line of force they become curved? If a positive charge is present here and negative charge is present here. I told you already, basically electric line of force is what? It is the path traveled by the unit test charge under the influence of point charge. So in this condition, if we are having positive and negative charge both, and we will place a unit positive charge here, then what will happen, beta? This positive charge will repel this unit positive charge. This negative charge will attract this positive charge. Then what will happen? In which direction the unit positive charge will move? It will not move in any direction, beta. It will move in the resultant force direction. According to the 11th class parallelogram law of retardation, you all know that. So it will reach up to here. Again the positive charge experience repulsion force, negative due to negative charge experience attraction force. It will not move here, it will not move here, it will move in between. And then if you will make this path with the help of this line with an arrow, then what kind of line comes? It becomes curve. So again I am telling you what is the definition of electric line of force. Electric line of forces are the imaginary line of forces. They may be straight or may be curve. Actually, it is the path traveled by the positive test charge under the influence of electric field of the source charge. Simple definition which you can understand. Here, one thing you can remember in your mind that for conventionally, we consider the test charge as positive. So all concepts, all fundas are based on when the test charge is positive. So here we can say that the test charge is always move in the direction of electric field. But anyhow, if you will take negative test charge, then what will happen? In that condition, all the rules, all the fundas, all the concepts just opposite. They become opposite. So by convention, we have considered the test charge should be positive. Okay, just remember this point. Now, after these electric line of forces, we have to come on the properties of electric line of forces, or you can say sketches of electric line of forces. So here, what you understand till now, see here beta, the first property of electric line of force that we can say, electric line of forces are radially outward from positive point charge. Just like this you can show. This is representing electric line of forces due to a point positive point charge. But if negative point charge is present, then what will happen? Then electric line of forces, they are radially inward. What is the exact meaning of radially inward, radially outward mean? What is the basic meaning of radial? Along its radius. Along its radius mean, if this is our point charge, then electric line of force, they always held in such a way, then it will exactly along the radius. Mean, on the surface, it always held at 90 degree. This is another property. Mean electric line of force always start or end accordingly. Mean electric line of force start from positive charge and electric line of force terminate at negative charge. And they always start, then they always be at 90 degree. If they end, then again always be at 90 degree. So always held on any surface where the charge is present, they act perpendicularly. Next property is electric line of force. I told you here, again I am telling you the same thing in a different diagram. Next we can say, if we are having positive charge, we are having negative charge. Electric line of force, they always start from positive and they end at negative. That we can show with the help of this diagram also. This is representing electric line of force start from positive and they end at negative. This is the electric line of force sketch again. Next is, if we want to explain the same property in a different way, just imagine beta. If here positive charge is present, no negative charge is present, then what will happen? The electric line of force may be straight. If positive charge is not present, negative charge is present, then electric line of force again comes straight. But here, positive and negative, due to presence of positive and negative, then what is happening here? The electric line, they become curved. They contract longitudinally. So in case of electric dipole, this combination is called as electric dipole. When two equal and opposite charges are present at a certain distance, that is called as electric dipole. So in case of electric dipole, electric line of force, they contract longitudinally, which is responsible for attraction force between these two charges. Next is, if both the charges are positive, then what will happen, beta? Then, if let's say we are saying it is Q1 and we are saying it is Q2, and in magnitude Q1 is equal to Q2, I am saying in magnitude because I have taken already both are like charges. Then I am telling you very small technique with which you can make it properly. Just draw it and divide half. Exactly, because the magnitude of both the charges are same. So in this condition, if just consider this charge is not present, then what will happen? Electric line of force tried to move from Q1 only in a straight manner. But because of this present, so it will what? It will do what it will do? It will repel this charge. So electric line of force start from here, but they go out, go away from Q2. They just go away from Q2. And this is the sketch of electric line of forces in case of two equal and same magnitude charge are present at some distance. Then, beta, if any one charge having more magnitude than the other one, then what will happen? In this case, in this case, what will happen? I'm telling you. See, if Q1 is more than Q2, in this situation, let's say it is Q1 and it is Q2, and the Q1 magnitude is more than Q2. In that condition, divide again but give more portion to Q1 because its strength is more, its value is more. So its effect should be more and its effect will be more. So in this condition, we will make electric line of forces just like this. And here we will show like this. This is the sketch of electric line of forces in case of two like charges, but when one having more magnitude than the other one. Next, okay, before next, what the explanation of this sketch? In this case, we can explain that electric line of forces, they exert lateral pressure on each other when both the charges are like, which is responsible for repulsive force between the two like charges. And if the magnitude of one charge is more, then it will show more effect. So to show more effect, its reason should be more. This is the explanation of this property. Now the another property I am telling you. If we have a curved electric line of force, let's say like this. Electric line of force start from here A and end at B maybe. And at one point we want to find out the direction of electric field at a particular point. This is the direction. Then at this P point, if we want to find out direction of electric field, then what we can do? Simply we have to make a tangential line at this particular position. And this tangential line will give you the direction of electric field at that particular point. Next is, two electric line of force never ever cross to each other. Two electric line of force never ever cross to each other, because if it do so, then what will happen? See, let's say they are crossing at point P, and make a tangential line on each line of force. It means at one point there are two different directions of electric field, which is impossible, as I already told you. So at one point there are two different directions of electric field, which is impossible. So it means two electric line of force can never ever cross to each other. And then electric line of force next is electric line of force never form closed loop, because if they will form closed loop, then we all know that electric line of force start from positive and they end at negative. But if they have to form closed loop, then they have to start from negative and they end at positive, which is impossible. It is impossible. And then next one is they make continuous curve. They make continuous curve mean if they start from positive, then they always end at negative. Mean they do not have sudden break in between. Just like this, maybe A and maybe B. It will not happen in any condition, because if should happen, then it is possible only when at A position negative charge is present and at B position positive charge is present. So it is not possible. So what the next property is? Electric line of forces make continuous curve. Mean electric line of force start from positive and they end at negative. in between they do not have sudden breaks. Next is, if we want to make strong electric field, then we can do, or we can make crowded equispace electric line of forces that will show strong electric field. This is strong electric field. And if we want to show weak electric field, then what we will do? Then we will make equispace but far away electric line of forces, mean the gap between two electric line of force should be more. In this condition, this will show weak electric field. This electric field will be weak. Next property is, there are many properties, beta. So one by one I am discussing all the properties and try to understand what I am telling you. Next is, electric line of force cannot pass through a conductor. If we are having a portion where the uniform electric field is present, then what will happen? We all know that electric line of force start from positive and they end at negative. But if we will place a conducting object between the strong electric field, conductor, then what will happen? Due to induction method, negative charge will induce here and positive charge will induce here. And electric line force start here up to this. And electric line force move just like this. Mean inside the conductor electric field is zero. This is a very good concept, very important concept which we use to protect sensitive material from strong electric field. I am telling you, if I am having a very sensitive material, let's say this is a very sensitive material which can damage in a strong electric field, then what will happen? If I will place in a strong electric field, it will damage. If there is necessity that I have to keep it inside a strong electric field, but I have to protect it also. So what we can do, or you can say what I have to do. In that condition, I will take a hollow conductor. In that conductor, I will place that sensitive material in the cavity and close it. In this condition, then what will happen? Electric line of force will not pass through the conductor. So after placing the sensitive material inside the strong electric field, I have protected it, and this phenomena is called as electrostatic shielding. I have shielded from the strong electric field. So this is called as electrostatic shielding. So again I am telling you, electric line of force cannot pass through a conductor, mean inside the conductor electric field is always equal to 0. But in case of dielectric, if you place dielectric inside a strong electric field, then electric line of force can pass easily through the dielectric. Electric line of force can pass easily through the dielectric. This is the big difference between conductor and dielectric. So again, I am just recapitulating all the properties again one by one. The first one is electric line of force start from positive, they end at negative. Electric line of force always radially outward from positive charge, they radially inward through the negative charge. Electric line of force, they always show, you can say, contract longitudinally in case of dipole, which is responsible for attraction force. Electric line of force exert lateral pressure on each other in case of two like charges. Electric line of force exert, or you can say electric line of force always held perpendicular on any charged surface. At any point we want to find the direction of electric field, then we make a tangential line. Two electric line of force cannot cross to each other because at one point they will show two different directions of electric field. If we want to show a strong electric field, we have to make equispace crowded line of forces that will show strong electric field. If we want to show weak electric field, then far away parallel line that will show weak electric field. And electric line of force never form closed loop because they start from positive, they end at negative, they cannot start from negative. Electric line of force, they do not have sudden breaks, or you can say they always be the continuous curve, because in between wherever they have to terminate there should be a negative charge and that is not present. And then electric line of force cannot pass through a conductor. Here electrostatic shielding also told you. In case of dielectric, electric line of force can easily pass out easily. Okay. This is all about related with the properties of electric line forces. This was my third module. In next module, I will come with the new topics. Thank you and have a nice day.